Marine autonomy is a hard problem, and in many ways, the open ocean environment is the most difficult domain for any watercraft to operate in.
Even given a stable physical platform, the disturbances associated with the ocean surface make mastering essential dynamics and control a significant challenge.
Autonomy in general is extremely difficult because you are trying to make a system that handles things that by nature we can't predict.
The disturbances of the ocean do affect the dynamics of our controls, and one of the ways we compensate for that is we have an anemometer, and we utilize that to measure the currents, and from there we compensate with our motor controller.
The maritime RobotX challenge tasks have been designed to represent individual real-world missions, but also to encompass the diversity of activities that we expect autonomous boats to perform out in the open ocean. Activities like transportation, oceanography, and environmental surveying.
Putting to sea over large distances takes time, so while accurate perception is important, an autonomous mariner must also be able to prioritize tasks effectively and adapt to changing requirements.
Rather than focusing on perception, we're looking at the autonomy and how you bring those different levels of perception together. Kind of like with a self-driving car, you can see the things out there, what do you do with it? And so we're starting to pull those together with this competition.
We know that this course can change any given time, so we're able to switch and move what mission we're running and key details about that mission rapidly and without recompiling.
In such a variable environment, flexibility and robustness are crucial. No matter how well teams prepare, their test conditions at home may not match those of the competition.
Boats will encounter unpredictable conditions both above and below the water and need to combine sensor data under high levels of uncertainty.
Combining sensor data ends up being useful because it provides you with more information than individual sensors alone could provide you. For example, on the boat we have a LiDAR and then we also have camera data. The LiDAR gives us these 3D points. When we're getting those points relative to the camera, things can get a little bit iffy about where they are relative to each other because you have to get the measurements exactly perfect.
In the future, we are trying to install some underwater sensors to make sure that we can actually see the terrain underneath and make sure that we don't hit them.
Being lost at sea is not just a figure of speech. One of the biggest challenges is making sure an autonomous boat can make it back to port.
So we're actually funded on a research project to do communications constrained path planning on the ocean. We're gonna have these boats out miles into the ocean, and that is terrifying. If it doesn't come home, that's it. Like, there's nothing else you can do. So these competitions are really great because we're getting rid of all the bugs in the software, all the bugs in the hardware that can go wrong, and we're just vetting every single system.
The progress being made here at Maritime RobotX is helping to give us confidence that we can send unmanned boats out to perform a mission and they'll return safely.
Keep up to date with the challenges involved in advancing ocean autonomy at robotx.org.